Welcome back to Ox Tools. I'm Tom. So today what we're doing is we're continuing on with this TIG welding of dissimilar metals. I want to introduce a different filler material that I've used to join stainless to copper and copper to copper. This material produces a reasonable weld, very low resistance for electrical purposes. We've actually measured it very carefully. So if you need to make a connection electrically, this is a really good technique for that. We've also used it to weld stainless steel to copper and make vacuum tight joints with it as well. I don't know much about the structural qualities of it, so I wouldn't build any bridges with it or anything like that. But it holds UHV vacuum. It does not off-gas. We've checked it with a residual gas analyzer, and it's very clean, and it's a low electrical resistance. Now, what we're showing here is a technique for joining stainless steel to brass, or stainless steel to copper, or copper to copper, which can be a tricky joint. This material melts at a lower temperature and behaves much like soldering or brazing, but with TIG welding, so without the messy fluxes and whatnot. So I got some bits cut over here at the welding table, and we'll do some test joints. And then a couple of viewers suggested that I break apart the joint that we did with the silicon bronze, which is the first part of this series. And we're going to take a look at that too. We'll bust that open and get a look at the weld there. So, I'm practicing my arc shots, my arc welding on video. So we'll see if I'm improving there. So I'm trying. Anyway, let's get an apron on. Let's go over to the welding area and let's put some stuff together.
Okay, so here's the sample that we did in the first video, welding dissimilar metals with TIG welding. And so we have 360 brass to stainless steel, and we got some welds on there. And a couple of viewers suggested that I try to break these, which we're going to do. I think that's a good idea. We'll see what this looks like. But I also wanted to show a different kind of rod also. We'll get to that in just a second. So I got some more blanks set up here. These are stainless steel. That's 360 brass, the square, and then this rectangular stuff, this is copper here. So we're going to do a couple different joints here with this other material that I'll talk about in just a minute. And but meanwhile, let's take this over to the vise and see if we can break that and get a look at and see what that weld looks like. Okay, so we got this in the vise here. This one's welded on both sides here, so I'm gonna pop this one loose since it's welded on one side, and will probably be a lot easier to pop loose. So let's set that in there. Get that in there pretty good, and I'm just gonna use a pry bar here, and we're just gonna try to lever that off, which it's coming right off. Okay, so it's. I think it's loose enough that I can alright, so it's failing on that side. See if we can get that up there. Well, that's it's failed kind of right through the silicon bronze material, which is actually kind of good. So its connection to the base material seems to be pretty good. So these materials dilute, well, the lower temperature materials dilute themselves a little bit. So that's actually not bad. That's I kind of expected it to pull out of the brass myself, but that was pretty good. Let's try doing something to that one and see if we can get that one. Now this one's welded on both sides, so that's probably going to take a little more elbow grease there. Let's try this. I got a pretty good purchase on that and get my snap-on pry bar in there. I think I'm just pulling it out of the vise now. Bent that. So that's quite a bit of force to actually bend a 3/8 brass thing that close. Let me try that again. Let's see if I can get it to break. I gotta put some gronk on that. Let's try that again. Okay, so I did it a little more suddenly. Let's see what we got. And once again, it broke on the filler interface there, which is kind of good. And let's see, can you see that pretty? Yeah, it's a pretty good shot. All right, so that was actually a fair amount of force to get that to break. I wasn't being shy on that, but and it broke right through the filler material. Anyway, I'd say that's a pretty good joint, you know, considering brass is a pretty wimpy material. Stainless is certainly stronger, but you know, you're not so you're not you know, lifting. You're not building a crane with this technique, okay? This is more of a decorative type welding application. So, okay. So got some strength. How much? Kind of hard to say. Okay, so here's our samples again: stainless steel, 360 brass, and copper. And this is the rod that we're going to use here. And what this is basically a silver brazing alloy, and it's got a really bad rubber band on it. Oh God. All right, so we're not going to use that end. So there's a reason to not use a rubber band to hold the rods together. It's actually kind of left a residue on there that's probably not conducive to welding. So, all right, anyway, so this particular rod here, there's two alloys here. This particular one is 15% silver, and then the rest is copper, and then a little bit of phosphorus. This one has a lower silver content, so it's 5% silver, 89% copper, and 5% phosphorus. So these are silver brazing alloys that you would normally use with a torch and on flux and that kind of thing. But they actually work really well for joining dissimilar metals at low temperatures with TIG welding. So I want to show these, and we're going to duplicate that joint that we just broke a little while ago. We'll kind of do the same thing. We'll probably do one copper and one brass. I don't know if I'll use both rods. I'll probably use the cheaper. This is cheaper because it's got less silver in it. We'll use this one. And I'll put the part numbers at the end of the video so you guys can see it. And I'll try to get some arc shots here so you can kind of see how this stuff behaves. And then we'll try busting these joints, and you guys can get a sense of how this stuff behaves. And I got a little bit of silicon bronze left, which is actually another good rod to join copper to copper. Maybe I'll find another piece of copper, and we'll do a straight copper to copper joint with silicon bronze too. So, okay. All right, so let me get set up for welding here, and then we'll do some welds. All right, so we're going to try this 5% silver brazing alloy, 360 brass to stainless steel. Okay, so you can see that came out pretty good. So this is the 5% silver, 89% copper, 5% phosphorus. So we got a little bit of zinc fuming here. So you can see that this is already a lower temperature type joint, and that stuff lays in there pretty good. So what we're going to do now is I'm going to leave that one alone. I'm just going to turn this around, and on this same piece, we're going to go ahead and attach a piece of copper here as well to kind of continue on with the test here. So we're going to weld copper to stainless here with this same rod, and then I think the final will be the copper to copper with the same material, the same filler material. Okay, so here's stainless steel to 360 brass, and then stainless steel to copper, and this is with this 5% silver, 89% copper, 5% phosphorus rod. Now, this piece got pretty hot just because it's copper and it conducts heat real well, but it's basically a low temperature process. This need not get to melting temperature to do this process. Anyway, I'm going to let this cool off a little bit. I'm not going to weld the backside here because what we want to do is we want to try to break these off and see what happens when we break those off. And then the last joint I'm going to do is copper to copper with this same material here, and we'll see how it behaves. Okay, so here's the basic machine settings. DC polarity, we're straight, I'm in high range, and I have my main current control set kind of at a maximum of, say, 200 amps, although I'm controlling it with the foot pedal. Remote current control, which is foot pedal, just a high frequency start. No pulsing, no funny business there, just kind of straight TIG welding. This would be the same types of settings you would use for stainless steel or steel. Okay? Okay, so this is the, 360 brass to copper with this silver brazing alloy. Now I haven't done anything other than just cool it off. Now I'll brush it a little bit. Now, one issue with this particular rod is it doesn't have a good color match between copper to copper, or brass to brass, or copper to brass. It ends up with kind of a dark, the weld is darker colored, so you don't get a good color match if you're doing something where that matters, okay, and sometimes it does matter. Okay, so we did this, 360 brass to copper, and then the last one we're going to do is we're just going to do copper to copper here like that, and I'll leave it open a little bit like that. It just makes the weld go a little easier instead of trying to generate enough heat to get it to flow there. So we'll leave a little gap like that, and we'll just run a little weld along that and see how it goes. I don't know. Let's go. Okay, so this thing's still hot here. This is the copper to copper that we just did, and I'm going to go cool that off, and then we'll brush it. I'll probably hit it. I'm going to hit it on the power brush. That way, you guys can kind of see this color match thing that I had mentioned earlier. So let me cool that off, and I'll brush it. Okay, so there it is, polished up. It's a little bit hard to tell in this. But if you grind that down and try to blend that all in, you end up with a dark line where this material is, or a darker line. So that's what I mean by color match. Maybe this doesn't illustrate that well, but anyway, there it is. So now let's go over and let's try breaking some of this stuff and see what we get. Okay, so here's our samples here. Let's first things first. And, you know, we broke this other one. This was the silicon bronze here. So this one here is this 5% silver, 89% copper, 5% phosphorus. We did the brass to stainless. So let's pop that one first and see what we get there. So if I can get underneath there. Something like that. Let's try that. Let's see if we can lever that loose. Oop, yeah, that one comes loose pretty easily. And we get a separation right at the stainless steel interface there. So, and remember, this is brazing material here. This isn't welding material. We're not welding here. This is it looks like a weld, but it's not a weld, okay? And there's the inside of that. So it looks like it pulled up a little bit of the stainless. Hard to say. It may just be arc scarring there. I don't know. Anyway, it had some strength, but not a lot. But you know, we're torturing that joint pretty hard. A weld on the other side would have increased the strength dramatically. Let's try the copper now. Actually, you know what? I'm just going to leave it right there. See if we can get underneath it and get this one going. Oops, same thing. So that one, the copper side of the joint is pretty good, but the stainless steel side of the joint is not so good. But once again, a serviceable joint for non-structural kinds of applications. Let's see. I can put that right back in there. Yeah, it's a clean fracture. Yeah. Boink. Okay. All right. Let me reset the camera, and then we'll try this one here. Okay. So let's pop this loose. So let's do the brass one first. So what I'm going to do is I'm just going to clamp it like this, and then I'm going to knock it over with a hammer. It only took me about a half an hour to pick out which hammer I wanted to use. I have so many choices. All right, so that puts that pretty good. So let's just see what we get. Twink. Okay. Now this one, let's see. Let's get this back up here. So this one kind of, well, it came apart in a different way. So we came off of the brass, and then we got into the copper. So this is probably closer to the ultimate strength of this material. Let's see if we can put that back together there. But it's a brittle fracture through that weld, so this material is not real ductile. I can say that. And as I started to hit it, I hit it a little high, and we opened up this copper one too. So let's do that one next while we're here. Flip that over. Yeah. Bink. Okay. So the weld lacks ductility, but it does make a joint. If the joint had its own mechanical support, you know, a tube inside of a bore or something like that, where it had its own mechanical support, and all this weld was doing was sealing it or joining something, it would perform pretty well. Don't weld any lifting equipment with this material here. This is probably not a good choice. Okay, so here's our test victims here. This was our original silicon bronze, stainless steel to brass that we broke apart. This had pretty good strength to it. We were able to actually yield this brass before the weld started to fail, so that was pretty good. And then the next one was this guy here, and this was our silver bearing filler rod. The weld did not exhibit any ductility and fractured kind of in a catastrophic way, although it's still a valid process for joining dissimilar metals. This depends on the type of joint and the performance needed in the joint there. So that's that one. And then this last one was our red metals joined together. So we have copper to copper here, copper with our silver, and then copper to brass with our silver. And once again, they exhibited the same qualities as this, roughly the same. No weld ductility per se. So it's kind of a hard weld. Anyway, I think that concludes this thing, unless somebody has a suggestion for a continued avenue of investigation here. I think we're going to stop here with this. Anyway, hope you liked it. I'll put the links up to this material here that we use, this 5 silver, and thanks for watching, guys.